In this video, we are in Unit 2 AP Statistics, and we are looking at Section 3.2 in your book, The Least Squares Regression. So we've already been talking about scatter plots and correlation and all of that, but now we're going to get a little deeper and we're going to talk about the regression line. Now, you should all be familiar with what a regression line is. It is a line we come up with based on the relationship of your x and y variables. So whatever your scatter plot looks like, we find a line that fits it the best. We've also called it a line of best fit to come up with that regression line. And it just models mathematically or algebraically how the response variable is changing based on the explanatory variable. So the way we write a regression line is right here. We've got y hat equals a plus bx. Now in your calculators, the a and the b are switched, I believe, or they write it ax plus b or something like that. I'm not sure what it is, I can't remember. But please keep in mind that in your regression line, certain things don't ever change. For instance, this a right here represents the y-intercept or the constant, and this b right here represents the slope. So that never changes. And the reason they write it that way in AP Statistics, I'm not really sure why they do that, but it is helpful because we are always going to write our equations in context, so we kind of need this space here to write out what x is, not just using the letter x. So, of course, the reason this is called y hat, the reason we have a little hat above y, is because that is a mathematical symbol indicating that we are predicting y. These are called prediction equations. We're using the explanatory variable to predict how the response variable will behave. So leading into extrapolation, what is extrapolation? Well, extrapolation just occurs when you're trying to make a prediction too far outside the domain, that's your x values, because the farther out you get from your domain of your data, the less reliable your predictions will be. So you just have to be a little cautious with that. So another idea we're going to talk about is a residual. A residual is a difference between your actual value of y and your predicted value of y. So let me give you an idea of what I mean by this. If we look at some ordered pairs, and let's say I create a regression line, I do my calculations, and I get something like that. Well, obviously that line is not going to go through every single ordered pair in your scatter plot, and that you can see the distances. So the distances are your residual. So that little red line there, that is a residual. Residual are vertical distances because they're the distance between the y values. So I want you to notice something. This ordered pair here in my data is xy, and it has a value that corresponds to it because it's the same x value because they're vertically lined up. But the y value is y hat because it is the predicted y. So that residual there, this is what your residual is right here, that distance between your actual y and your predicted y. That is what your residual is. So if you ever have trouble remembering if it's actual minus predicted, which students often do struggle with that, actual, a big A, P, a big P, you're in AP. See, actual minus predicted, you're welcome. Okay, so some other things we need to talk about here, interpreting our regression line. Well, since a regression line consists of a slope and a y-intercept, we are going to interpret a regression line based on your y-intercept and slope. Now, exactly how we're going to talk about this, it will get more specific in examples, but keep in mind that your y-intercept is always the value when x is 0. So if you have a prediction equation that looks something, like that, obviously, we're going to have values for a and b, And then x and y are going to be whatever our variables are in context. And so when x is 0, that is an indicator of what this value is right here without x. So if we're talking about some kind of context, whatever x is, if it makes sense for x to be nothing and y to be something, then it will or will not make sense. So we're going to talk about that in an example. When we talk about the slope, please keep in mind we are always referring to the slope changing in an increase. So x is always increasing. So when we talk about the slope, we're going to be talking about the idea that for each additional value in the x variable, we can expect y to respond by that by either increasing or decreasing, depending on if your slope is positive or negative. So we are going to talk about that as well. The least squares regression line is called the LSRL. The reason we call it the least squares regression line is because it's the line that makes that sum of the squared residuals as small as possible. So why is that important? Well, if you'll look at your line here with all of your ordered pairs, if I square those, then I'm going to have that distance. I'm going to make that distance as small as possible so that my line fits exactly where it should be. So that is, it's a mathematical calculation that you won't ever have to do by hand. But that's a little bit about your regression line.